Hello everyone, welcome back to my channel. Thank you so much for being here with me, and this is Isah. If you are new to this channel, you are welcome. Kindly like this video, give it a thumbs up, and subscribe to my YouTube channel. You are doing this, you are helping me to grow. Please don't skip this video without subscribing. Thank you so much, I really. And what we are going to be looking at is time series forecasting. Whether you are into finance, whether you are into finance, sales, or even metrology, predicting future trend is a very important and a game changer for anyone. And guess what? So Python has some incredible libraries, time series forecasting easier and more accurate. I want you to stay with me to the end of this video as I walk you through the best tools for time series forecasting. My name remains Isah, and thank you for joining me. So the first thing we're going to be talking about, what are we talking about? Time series forecasting. What is it about? So time series forecasting is a powerful tool for business. It allows businesses to make informed decisions, optimize resources, and stay ahead of their competition. So imagine knowing the future sales trends, predicting stock prices, or even forecasting weather patterns accurately. It will help so many things and so many businesses and make life easy for everyone. So this knowledge can save money, it can increase efficiency and boost profitability. So what are examples use case of time series forecasting? You can use time series forecasting in retailers predicting sales to optimize inventory, financial analysts forecasting stock prices for investment, and weather forecasting for agricultural or disaster management. So time series can be used in different fields. All right. And in this video, I'm going to show you how we can use time series in the traffic of my website. So we use the current traffic that we are getting to predict future. The next thing we'll talk about, kindly like this video, give it a thumbs up, and subscribe to my YouTube channel. Time series data and its characteristics. So before we jump into the libraries that we are going to be using, let's understand time series data. So unlike regular data, time series data is sequential, meaning that each data point depends on the previous one. So some common characteristics include like a long-term upward or downward movement trends, the seasonality, recurring patterns at a fixed interval, then cyclicality, which is that are not fixed, like economic cycles, then irregularities, unexpected spikes is due to anomalies or outliers. All right. So time series, these are some of the characteristics of time series. Let's look at the major challenges of time series. One of the major challenges of missing values and outliers means, or you are new to the world of data science. So when we talk about outliers, is the distinction, the one out of many things, the one that stands separate from the rest is what we refer to as an outlier. So non-stationary data where statistical properties change over time. So it's another challenges, okay, and can complicate forecasting. So I don't want you to worry, because in this video I'm going to show you the right tools to fix these issues. All right. Now let's talk about the essential Python libraries for time series forecasting. Number one is Pandas. So Pandas is great for data manipulation and pre-processing. So it helps handling missing values and prepare data set. Then we have numerical Python, which is NumPy. So and it's very essential for numerical computing and array operations. Then Statsmodels, so which is perfect for statistical models like ARIMA and SARIMA. Don't worry, we'll talk about this as we move forward. Then we have scikit-learn, so which is widely used for regression models. They have library by Facebook, which is used and is very powerful for business forecasting. Then we have TensorFlow by Google and Keras for deep learning models like LSTMs. Don't worry about this as abbreviation. We'll talk about them as we move forward. Before we move into the coding, this is what I have been able to work on. So this is a quick example using a Prophet to forecast website traffic trend. All right. So we started from year 2025 and we next 365 days. So now, okay, so now let me explain what a Prophet. The Prophet library is a flexible open source library that is built on top of the Python library. All right. And it uses a decomposable model that breaks down a time series into several components like trends, seasonality, and holidays. So the model then uses this component to make predictions about future trends. So and we will see that in a jiffy. All right. So as you can see from here, from Prophet, we are importing and then we are using a console because we want to get the color. We want to add color to our tables and rows. We're also importing table from rich table. All right. Now the first thing I did is I create a CSV file of so from in January I was having at least 100 visits on my website. All right. So this is based on assumption. Okay. So I did it that okay, monthly I am getting 100 visits on my website, and you can check my website out .com. You can check my website and check jacobisah.com. All right. So now I now see it as a .csv file, and then we're now importing it here and calling the file. Okay, here we are loading the file, then here we are converting the file format. So conversion is taking place here so that we'll be able to know what we'll be able to convert it from a CSV file to a data frame that can be read by Pandas. But one key thing you must know here is the DS column is used for date time and handle invalid dates. Alright, kindly like this video, give it a thumbs up and subscribe to my YouTube channel. It's used to convert the data that we have and then also to handle invalid dates. And then we move forward here. We are now dropping rows and invalid dates here. So that's why we are calling the drop not a number function there. Alright, so missing data is used to get missing data. Then we now initialize prophet. Okay, here we are initializing prophet and then fitting the prophet model. So we are calling the fit method and passing our data, our CSV data that I've already converted and worked on. We are passing it inside the model so that it can fit the prophet. So after that, we now create a data frame. Okay, we're now creating a data frame with a period of 365 days. That's 1 year. So we're now looking at the trend for the next 1 year. And then if you look at what we have, we can now make predictions. So that's why you can see I use forecast here. So we are now making prediction and then passing our future data frame here. Now we're now passing it inside the predict. Okay, so that we can now make predictions. Then we now plot our forecasts. All right, so here we are plotting. Even though we are plotting, we need to also plot the forecast components. Remember what I said. So the prophet will use these components. All right, so like trends, weekly, seasonality. We now move down to where we are now printing the forecasted value with colors. All right, so that's why we are using the console, created a variable console, and then we are calling the console object. We import it from the original. Then we're also using the table. We are using to put everything together in a table. So we have the column for date, we have the column for predicted traffic, and then with color green. Then we have a lower bound and upper bound. Then lastly, we now add rows to the table. Remember, these are columns. Okay, these ones are columns, so we need to add rows. So we are looping through the index row in the forecast. Let's print the table to see what we have. If we come here, let me try and activate the virtual environment time series.py, able to get result now. Okay, so from here you can see the prediction that we are getting. So it's giving us from 2025 to 6. So this is March 1st 2026. So by then we should be having 4,400 traffic coming in. So now let's go to the heading to see the title very properly. So here we are starting from March 3rd in 2020. Okay, and then predicted traffic will be by March 3rd. We should be having 700 traffic coming in daily, and then the lower at least should now be the low that will come in, and the increase will be 706. Look at where it's starting from. It's starting from March 2025, March 2nd. Now let's look at CSV file. If you look at the CSV file, it's starting from January 1st 2025 with 100. So this is how we use prophet to predict, okay, the future trends. There are questions that you may have here. Questions like, how are we sure this is correct? We'll get to that point where we evaluate what we have done so far. If you look at what we have done, we can now talk about the differences, understanding the different forecasting models. There are different forecasting models that you can use. Kindly like this video, give it a thumbs up and subscribe to my YouTube channel. We have autoregressive integrated moving average, which is the ARIMA, and is best for linear trends and stationary data. Then we have SARIMA, which is seasonal ARIMA, which is seasonal autoregressive integrated moving average, which also handles seasonal variations, but it is more better than ARIMA. All right. Then we have the prophet, which is the one we are using. So prophet is easy to use and handle missing data well. Then we have the long short-term memory network, which is the LSTM, so which is used for deep learning models for complex patterns and long-term dependence. These are different forecasting models that you can try on. Now let's compare ARIMA and LSTM. Okay, autoregressive integrated moving average and long short-term memory. ARIMA is a statistically model that relies on linear relationship and historical data, while LSTM is a deep learning model that can capture complex non-linear patterns and long-term dependencies. So ARIMA is great for simple pattern, while LSTMs is shine in deep learning applications. So the difference is clear. So when you are choosing your type of data set you are dealing with, you should determine the model you want to use. Complex data, you are dealing with complex data or historical data, and you want to make a prediction based on that historical data, ARIMA is your choice. Okay, but if you are if it's about a deep learning and your data is non-linear patterns and the prediction is going to depend on long-term, LSTM is the best option. So always know that choosing your model, it depends on the type of data set you are dealing with. Evaluating and refining forecasting results. So now back to the question that I was asking earlier. So how do we now evaluate and refine our code so that we will know that our forecasts are accurate? So for us to do that, we'll use the mean absolute error, which measures the average absolute difference between actual and predicted values. Then we talk about the root mean squared error, all right, which penalize larger error more than the mean absolute error. So now let's update our code so that for evaluation, so that we do our code and see how it works. Now we've now updated our code with the test so that we can evaluate our actual results. So we are merging the prediction with the actual value. Okay, so that's why we're calling the merge function, all right, and then passing in our data. Then we're calculating the evaluation metric, the MAE, mean absolute error, and then mean squared error, and then we are passing in all of this. If we now run this code, let's run this code and see the mean error, the mean absolute error, and the mean square root error. So let's run it. Our mean absolute error is 1.88. Our mean squared error is 14.42, while our root mean error is 3.80. So you cannot say that you will make prediction and will be so accurate. So but you use this metric to check whether what you're doing is correct, all right, and it puts your program under checks, all right. So this is how you can evaluate your code, be sure that it's meeting and is doing what it's supposed to do, all right. So let's move forward. Okay, so we have just talked about this now. So by fine-tuning parameters, adjusting data set, and continuously monitoring our model, we can improve forecasting accurately. So the first time you make forecasting does not mean you are accurate, all right. So but the more you progress, the more it improves. And that is what is happening with the ChatGPT. As you are using it, is learning and adjusting. So over time it adapts to patterns. Okay, it learn over time, gain enough information, all right. So we can improve forecasting accurately when we continuously monitor our models. In conclusion, I want you to know that time series is an invaluable skill for businesses and analysts, both data analysts. Okay, so and with Python powerful library, you can create accurate predictions and make data driven decisions. So if you found this video helpful, give it a thumbs up, subscribe for more data science content, and drop a comment on which library you prefer for forecasting. See you in the next video. Bye bye.